Hi guys, how's it going? Trying a little bit of a different format video today. This is my second time to do it because I've never used this software before, and of course I messed it up the first time. What is this video about? My clutch is finally bedded in on the stage 2 240 brake white VRS, so I've been eager to pull some data off it and see how it's responding, which overall is excellent. There's only one thing in here that concerns me. I say concerns in the sense that I don't have all the data I need. I can't see some of it, but I don't anticipate any issues. So basically, what I've done here, my diagnostic tool of choice for this is VCDS Rostec, which is excellent for anything Volkswagen Audi group, which Skoda is. I've basically pulled off some data logs here and a couple of measuring blocks. My approach when doing this is if you want to think of it this way, how can I replicate a dyno run on the road or as close to as possible? So I want to bring the engine down to a low speed, so kind of like 1500, 2000 RPM ideally. And I want to basically match the throttle, so I put the engine under 100% load and bring it up to the red line or as close as possible. So, not always easy to do. Obviously, you need to work within speed limits and traffic, etc., not being reckless. So, the data is never going to be perfect, but you have to work with what you have. So, what have I done here? So I've got 4 pulls of clean data off this. I picked a couple of measuring blocks here, so 7, 11, and 20. So in kind of the way this software works is you will have, groups of measuring blocks. So these are PIDs. I can basically pull info from the ECU, and they have a couple of different parameters grouped in. So the ones I wanted to look at in particular were, I'm hiccuping, excuse me, Christ, oil temp, air intake temps, coolant temperature I wasn't really concerned about, but it all looked perfect there. Boost pressure, so I'm actually looking at how is the boost control working, and this is the one that's worth talking about. So we have a specified value from the ECU and an actual value which is recorded from the map sensor, manifold, absolute pressure sensor. And the final one then was my fuel pressure in the rail. And again, here I'm looking at the actual versus specified. So what I'm most interested with the fuel pressure is my fuel system keeping up? I.e., when I start asking for higher duty cycle through the injectors, more open time, more fuel volume through the system, is the pump able to, I suppose most importantly, the high pressure pump, is the high pressure pump still able to provide the pressure in the rail that the ECU is requesting? When it's not, that's when you need to start looking at fuel pump upgrades, and in this case, thankfully, that is not the case, which I'm very happy about. So, right, let's scroll over to the right here, and we'll talk through this. So, as I say, I've kind of made this a little bit more manageable for myself, and I've put it into 4 pulls with clean data, and then I've put it into graphical format, so it's easily digestible. So what's worth noting here, so the first thing I've plotted this line down the bottom. So this is our ambient air temperature here in Kilcolgan, County Galway. A balmy 14 degrees Celsius. So why have I stuck that on here? So if you think of any charge cooler, and this one specifically is air to air, so it's a front mount intercooler, and that's the factory setup. If it was ever possible, and it's not, for thermodynamics reasons, and the whole, I won't get into that, I was going to start talking about that, but that's a conversation for another day. If our cooler was 100% efficient, it would mean that the charge air through the system we could cool to the same as our ambient on the given day we're looking at it, which is 14 degrees. That is not possible. So you always have some inefficiency in any system. What will I say? What to say about this? My expectation based on experience was telling me I am going to see minimum 40, if not into the 50s intake air temperatures, and surprisingly we're much lower than that, which is fantastic news, and I was so happy to see that. So what's worth to talk about here? Let's look at the peak values. So pull 2, our peak value was 36. Again, as I say, we're looking to maintain air density, keep as much oxygen in the charge air as possible. So when we're talking about these kind of numbers, really, really good. I wouldn't be looking to make any modifications here in terms of changing intercooler setup or anything like that. If you're on track setup and you're leaning on it continuously, you probably will start to see the system heat soak. In those applications, obviously, your requirement for modifications is different. So I'm looking at this from if I'm doing a spirited drive, am I going to see problems? You're letting the system cool back down before you go into another run. In the real world, am I going to see any issues here? And the answer is no. And as you can see here across the runs, pull 2, we do see a little bit of creep in temperature towards the end, and I'm obviously pulling out of it. But mostly across the board, like we'll look at pull 3 here, we're starting at 29, we're finishing at 32. Excellent. Really, really pleased with that. Oil temp, again, is a similar good news story. Broken this down in 2 runs again. Sorry, my screen's kind of lagging there. Obviously, again, with pulls, we'll start to increase oil temp, so it will go up and up. But through the runs, we're not seeing actually any. Now, I don't know what frequency this temperature sensor is reporting. It's the one that's in the sump with the level, I believe, in these. So there will obviously be some delay as it goes through the system, the turbocharger, everything, and then back into the sump. And it's the whole volume of the system, which is like 4.5 litres in this, if I think. Right. So yeah, absolutely nothing of concern here. My peak value was hitting 92. So again, excellent. Fuel pressure. So as I say, this one, I probably normally split it into 4 separate graphs just to look at the command for each one versus the actual. But as soon as I dumped the data on the graph here, I was like, wow, I don't even really need to, because it's stacking up so nicely. So as I say, let's see what's the peak value here. 1880 bar. We're not seeing anything, as I say, we're not seeing it take any massive dips here and try and come back up or anything like that. So as I say, that's telling me my high pressure pump is keeping up with the demand now for the additional duty cycle on the injectors, which again, fantastic news. The last one, which is the one I say is maybe, I say of concern, but it's just that I'm not seeing all the data I want here. So what sticks out here, and I think if you're even not familiar with these kind of systems, it's pretty obvious. We're hitting a value here of 2601 and it's flatlining. So straight away I know I'm at the limit of my sensor, my map sensor. And I've seen this before. So my spidey senses were saying there's a 3-bar sensor in this, so that led me to, if I can kind of bring you along here, will it let me? Yeah, so easiest is to go into the parts catalog for the vehicle. I've gone into my charge air system and I know that 18 is my manifold absolute pressure sensor. And I was expecting, 051C, which is the 3-bar absolute pressure sensor. Did I mention that? I talk on that. I hope I haven't mentioned that yet. So 051C, and again, if you look on somewhere like Dark Side, there's the 3-bar map sensor. Now you say 3 bars, so let's go back into here and talk about this for a second. Okay, so 3-bar manifold absolute pressure sensor. The A in that is key. Absolute pressure is inclusion of ambient air pressure as well. So the control units will include this, as air pressure obviously fluctuates with temperature and altitude as well. So we want to be mindful of that in all the calculations in the ECU. So we're looking at absolute pressure as opposed to gauge, which takes out the ambient air pressure. So what to note here? 3-bar or 3000 millibars, will you say? Well, hold on a minute, you're flatlining it to 2601. Would you not expect it to go up to 3000? The sensor calibrations, we'll look at this in a minute. As far as I remember, I'll double check that now here, but while they do go to that value, the typical calibration used in the ECU is lower. And I know from experience that it's not uncommon to see a value like this as your peak reference for that sensor. So it will be on a 5-volt reference, and your output then is obviously a millibar versus a millivolt, and that's how your calibration is done. So that's not surprising. So what am I going to do here? So I suppose first of all, let's just talk about what we can see, and we'll look at our orange pull 1 versus pull 7 actual. So again, the points here might not be perfect because it's dependent on the inputs here, which is my right foot essentially. At full load, we're looking for 2601. Now I'm just going to look at pull 1 here in purple. So the response, I can tell, is pretty good so far. There is obviously a ramp, and these are PID systems. So the boost control is looking at actual value versus specified in the ECU. There's then a base map for the duty cycle sent to the N75 valve, which is a pneumatic solenoid valve, which is pulsed to basically, how would I say, determine the amount of vacuum that is sent down to the actuator on the variable nozzle. So what you will see, like any kind of PID system, is you would typically have an element of overshoot, an element of undershoot, and then it will start to level off. So as I say, the response here looks quite normal, but I can't see above that, and that's, again, I don't anticipate I have any issues, but at the same time, I want to see exactly what's happening. So my next protocol here will be to move up to a 4-bar map sensor. Excuse me, I will get on to the guys in Top Gear Tuning and ask them to recalibrate for that 4-bar map sensor. God, the hiccups today are ridiculous. Excuse me. And then I will repeat this testing just to see exactly what is happening. So as far as my command in the ECU is going, we're targeting 1.6, but as I say, our sensor is only allowing us to see up to that, so there will be an element of overshoot. We may hit 2700 millibars absolute and even above here. I suppose on that same train of thought, on the undershoot element, if I can maybe zoom in here a bit. Kind of lags a little as I'm doing this, apologies. It's having a slow day. Okay, so I'll talk here while it's refreshing itself, but I would say, and again, this is an experience thing, I'm not seeing massive undershoot in the data here, which would indicate to me there isn't massive overshoot either. you will see, and I've seen this before in the past, tuning hybrids. Now, I suppose it's a long time since I tuned a hybrid, and I'd imagine they're probably better set up now with improvements in technology and the machines used to calibrate the variable geometry turbines. But I had a lot of issues maybe 10 years ago tuning hybrids where I would go in, we'd set the actuator, we would tune the duty cycle in the N75 map, and then with the customer we'd do data logs again, and you'd see basically the system was struggling to make pressure where you wanted it. So your error would be huge from the actual versus specified. And as the error multiplied into the system, it basically sends a signal to, again, your V&T in this case, to close the turbines down more and more to speed it up, speed up your shaft speed and get some pressure built. What happens then is you're telling it to close the turbines more and more. Your engine speed is increasing, again in a high load situation. Your mass air volume through the engine starts to increase, and all of a sudden you get this, as the turbocharger comes on, a huge boost in volume of air through the engine. Your boost pressure skyrockets, and next thing you're overshooting to the moon, and the system is going, oh fuck, we've really, shot past the moon here, we need to turn around and come back a bit. And then your system is struggling to keep up. So you end up with this massive overshoot, massive undershoot, and the system takes ages to settle down. So, as I say, in those cases, we're trying to tune it out through the N75, but there's only so much you can do. You can't tune out a hardware problem with software. So you have to work within the realms of what's physically possible, and you base your software tune on that. So what can the system physically do? Okay, I know I can't make 3 bar of pressure at 900 RPM. So be realistic. I'm not going to ask for that pressure there. And even if you could, you blow clutches and gearboxes and everything into obliteration. So physically that's not possible, but even if you could, there's an element of, okay, what should I do here, being mechanically sympathetic, shall we say, as well. But yeah, as I say, I can't see the data above this because I'm at the end of my sensor. And let's click here into, I had a tab open, didn't I? So the 051C, as you see, that's the 3 bar. And I'd want to go for a 4 bar next. I got this data sheet, but this isn't the exact one for the sensor. But it kind of gives you a feel for what's going on. So the temperature here, so as I say, I was looking at IATs. So the IAT values I was looking at for intake air temps is pulled from the map sensor, which is really valuable in the sense that it's post-charge cooling, and it's right before the EGR or anti-shudder valve in these. So it's a very good indication of what your temperature is actually, or close to as you can read before it gets pulled in and combusted. So that's really valuable for us. And as I say, that's done on, these are 4 pin if I remember. So there's your 5 volt reference, ground, your signal for the manifold absolute pressure sensor, and then the signal for temperature. And the temperature is used in density calculations as well. So looking at the pressure here, so I think that's 300 kPa or your 3000. And then your output voltage here. So as far as the ECU is done, it looks at millivolts for these Bosch ones, but you're up to 4.65 here is your output at your 300. But as I say, in the ECU calibration, I pointed at the screen like you're looking at me, we're probably about here, we'll say, and that's kind of where I'm maxed out. So yeah, my next port of call will be to probably order from Darkside here, or maybe avoid the customs tax. It's the small probe 4 bar map sensor. So this guy, load, and then as I say, I'll ask the kind folks in Top gear tuning to make 0 changes to the Mac bar, recalibrate for the 4 bar, and we'll pull some data off it. And I might revisit this again just to look at, but yeah, physically the same size, but the calibration obviously allows me up to 4 bar. So we'll say, if I jump back to this graph here again to explain it, as I say, we have our 5-volt sensor reference, and our max pressure here is 300 kPa, or 3 bar absolute. So in this case, our calibration will change. We'll see 400 here, or 4 bar. For our, again, it may be a little bit different, but let's say it's the same 4.65 volts, or 4650 millibars in ECU figures is what we'll see. So yeah, as I say, across the board, I'm delighted. The only thing that was of slight concern, or maybe something I just want to deep dive into a little bit more, is the charge air pressure, because I can't see above 2600 millibars absolute. So yeah, I'm really pleased so far. So that'll be, if you want to call it, a modification next. It's not a performance modification, but it's a peace of mind modification for me, to basically see what's going on. So yeah, a little bit of a different format today, but something I've kind of done a lot, and this may not be to everyone's taste. So sorry if you watched this far and you're like, oh, that was fucking boring and I didn't learn anything from it. Completely understand when some people are coming to get cars tuned, they don't really care about this, and as I say, I completely get that. Then I know there's the other side of the fence, where there's people like me, and they're really interested in kind of the nitty gritty and what's changing. And if you want to look at the setup you're running, if there's any limitations in it, if there's any areas for improvement, again, I'll say, look at, where do you draw the line in the sand? And this car was a particularly good example. I probably went a little bit overboard on it. What is the end use for the vehicle? Are you going track racing it? Are you going to bring it to drag races? Is it a fast road setup? You know, you're going to see different requirements for different applications. So if I brought this car on track now and I'm beating on it for 20 minutes, 30 minutes at a time, not giving it a chance to cool down, I'm going to see different issues. I'm going to see coolant temperature creeping up. I'm going to see oil temperature creeping up. Excuse me again, hiccups, Christ. And in those cases, I might say, okay, I'm racing this. Maybe you're doing professionally, maybe you're doing it for just fun track days, but you want to push the limit. You know, if you're doing track days, you want to push your limit capability wise, and your vehicles, you know, you want to see who runs out of talent first, the car or you. So I would say in those scenarios, you might say, okay, I am hitting really high oil temps. I need to look at external oil coolers. I'm hitting high oil or coolant temps here. I maybe need to look at an alley rad setup, or in some cases, you might need to look at a thermostat that opens slightly lower as well, just to give the system a little bit more of a chance. Again, are you going to see that issue if you're, you know, doing a pull once every 10 or 15 minutes on the road? No, you're not. So different strokes for different folks and all that kind of thing. So yeah, you need to look at, put the vehicle in a real world scenario. You know, if, again, I suppose if you're like that doing track days, I would be looking to, and this isn't hard to set up at all by any means, and if anyone ever wants to know how to set this up, you don't need fancy diagnostics. You can have a Bluetooth dongle, like the Elm knockoff ones with Torque Pro app, which is like €8 on Google Play or something like that, and you'll get all this information off it as well. So you don't need fancy setup. If you want to know how to do this, just let me know. I'm happy to help. Rather people not blow up engines and stuff. So yeah, always a good idea to do this. So as I say, if you're maybe a little bit concerned, you're doing track days, even fast road, and you want to see what's happening, 100% do some data logging like this. It's free information, and as I say, it could be the difference between you saving an engine and killing it. So do it is my advice. Yeah, more than happy to show people how to do this and what to take from it as well. So I say this a lot. Not all data is useful, so you want good, useful data as well. So you don't want to just be plugging in a diagnostics, go down the road reading stuff, and half-assed going, oh, that looks a bit funny. You want to, how would I say, nearly structure a test plan. What do I want to get out of the data first, and then accordingly work back from that and say, okay, how am I going to test to give me accurate data to prove out this point? Can I see is my fuel system working okay? Is my charge pressure control working okay? So on and so forth. So yeah. As I say, I hope some people find this interesting. This is diving deep further down into the rabbit hole, but I wouldn't often do this for, say, stage one on standard hardware and stuff like that. When you start going beyond that, we will do this. There is no, for me personally speaking anyways, there is no option where we don't do this, because you are obviously pushing outside of the kind of normal limits and changing hardware, etc. So stage 2 onwards, we will always data log here at Ionics Works. So yeah, I'll wrap it up there, and thanks for watching. Have a good day. Bye now.